Welcome to homework.
Okay, so since we need to know the current through each resistor in this figure, we can see that um, each resistance has a value of 3.25 kilo ohms and the voltage of the battery is 12 volts. Now, to get the current, we first need to find the total current that's passing through the circuit, because if we look at this resistor, so this is in series connection with this guy. So that means, and since this is directly connected to the battery, that means the whole current is passing through R6. So that means we need to know the full current. And to do so, we can actually simplify the circuit. And as you can see, I have simplified the circuit till this end. And let me explain what I did here. So first of all, as you can see, between A and B, R1 and R2 is in series connection. So I replaced R1 and R2 by R12, and then the rest of the circuit is the same. But then between point A and B, R12 and R3 are in parallel connection. So I replace them with this and R123. So this is the circuit, new circuit. And then as we can see that between points A and C, R123 and R4 is in series connection. So we replaced these two guys by this equivalent circuit, which is R1234. And then we have parallel connection of R1234 with R5, and we replace that by R12345. And then this resistor is in series connection with R6, so we replace them by REQ. Now we can actually find out all the values for these resistors. So let's get on to it. So first we need to find R12. So that's gonna be R12, which is equal to R1 plus R2. And since they all have the same resistance, so that's going to be R plus R, which is 2 times R. Then for R123, this is going to be, since it's a parallel connection between R12 and R3, it's going to be this, and then we'll have 1 over R12 plus 1 over R3 reciprocal. And if we plug in the expression for those, we get 2 over 3R. So you guys should try doing it by yourself so that you get some practice. Um, okay, moving on. So now we have a series connection. So that means R1, 2, 3, 4 is going to be 2, 3, 4 is going to be R123 plus R4, and which is nothing but 5 over 3R. Then we have a parallel connection, so R1, 2, 3, 4, 5, that's gonna be 1 over R1, 2, 3, 4 plus 1 over R5 reciprocal, and that gives us 5 over 8R. Right, and finally R equivalent, that's gonna be a series connection between R1, 2, 3, 4, 5 and R6, and that's gonna be, let me write that down, 1, 2, 3, 4, 5, 6 plus R, sorry, that's gonna be 1, 2, 3, 4, 5 and R6. Yeah, and that is gonna be 13 over 8R. Right, so now we know, we simplified the loop. Now we can go backwards, and uh, because we need to go backwards to get the current, because so that's our equivalent resistance and we know the total voltage. So using Ohm's law we can get the equivalent current. So that's gonna be IEQ, which is equal to the voltage of the battery over the equivalent resistance. And if we plug in the values here, or let's just plug in this guy over here, and we get 8 epsilon over 13R. And this guy right here is same for R6 and R12345, because as we saw that this is a series connection, so the current passing through this circuit and this circuit will be the same. So this guy is equal to I6, which is equal to I 1 2 3 4 5. Right. And then if we look at the circuit diagram again, we see that V5, so V5 is the voltage difference between A and C, and so this guy is equal to V1234 because it's a series connection, and that's equal to V12345, because again this whole guy is this circuit. So let me write that down. So it's gonna be V5, which is equal to V1234, which is V12345, and according to Ohm's law, it's going to be 1 2 3 4 5 times R 1 2 3 4 5. And if we replace the values, we'll get 8 epsilon 13 R multiplied by 5 over 8 R. So this guy right here is R12345, which is this, right? And I5, so I5 is going to be V5 over R5, and that's going to be 5 by 13 epsilon over R, which is 5 epsilon over 13R. And yeah, that's our I5. And I1234 is, so I1234 is the one that's passing through this guy, so that's gonna be voltage V5 or V1234, they're the same, so V1234 divided by R1234, and that should give us 5 over 13 epsilon divided by 5 by 3R, and that gives us 3 epsilon by 13R, which is I4. Because again this one is a series connection between R123 and R4, so I4 should be the same as I1234. Okay, right. And of course that's going to be I123 as well. Right. Now we will see this relation V123, which is equal to I123 times R123. So if we go back to the diagram, it's basically this part. So we can again plug in the numbers. That's going to be 3 epsilon over 13R for I123, and R123 was 2 over 3R. So that should give us 2 over 13 epsilon, which is V12, which is V3. So V123 again, so V123 is a series connection of R3 and R12. So that means the voltage between this and that will be the same. Right. So now from there we can figure out I3, which is passing through R3, or here passing through R3. So I3 is going to be V3 over R3, and that's going to be 2 epsilon over 13R, right? And I12 is going to be V12 over R12, and that's going to give us 2 by 13 epsilon divided by 2R, which is simplified as epsilon over 13R. And this guy is basically I1 and I2, because I12 is a series connection um, between R1 and R2, so that means the current is the same. So that's why I1 is equal to I2. So now we know all the currents. We can actually plug in all the numbers, and I'm going to give you the values so you can actually plug in the numbers. We know that epsilon in our case is 12 volts, so we can plug that, and R in our case is 3.25 kilo ohms. So R is going to be 3.25 kilo ohms. Yeah. So if we plug in all the numbers, we'll get the following values. I1 equals I2, which is 0.284 milliamps. I3 is going to be 0.568 milliamps. I4, let's write it here. I4 is going to be 0.852 milliamps. I5 is going to be 1.42 milliamps. And finally, I6 is going to be 2.27 milliamps. And what else? And okay, so we need to find the potential difference between point A and point B. So potential difference between this and that. So we're going to use, let's see, so it's going to be V3. So we're going to be using this guy, right? So we're going to be using trying to find this guy. So it is 2 over 13 epsilon. So VAB is 2 over 13 epsilon, and that should give us 1.85 volts. So yeah, it's better to derive this so that it gets clear. It's a very simple problem if we actually simplify the circuit. Thank you.